Properties of rational exponents and radicals. The properties of integer exponents that you have previously learned can also be applied rational exponents. So the properties of rational exponents is let a and b be real numbers and let m and n be rational numbers such that the quantities in each property are real numbers. So the product of powers states that if I have bases that are the same, so again, I have an a there and I have an a there, and when they're being multiplied, then I can add the exponents. So that should be seen as a plus there. All right, it didn't do a good job of copying that. But for the example, they show you a good one. So I have 5 to the 1/2 power times 5 to the 3/2 power. So again, the bases are the same. They're both 5s. And then I can take the exponents and add them. So 1/2 plus 3/2 is equal to 2. So 5 squared is equal to 25. Power to a power, again, if I have a base of a and I have m raised to the nth power, then I'm just going to multiply them. So, and again, you can see by the example there, the power of the product rule is if I have 2 of them together, I can separate them. So if I have a times b raised to the nth power, I can have a raised to the nth power and b raised to the nth power. Again, they're giving you an example there. So the half root of, not the half root, raised to the 16 raised to the 1/2 power, which is the square root of 16 is 4, and then the square root of 9 is 3. So again, that would equal 12. The negative exponent, if I have a negative exponent, I can put it on the bottom. If it's negative on the bottom, I can move it to the top. The 0 exponent, anything raised to the 0 power is equal to 1, except 0 raised to the 0 power. That one can't happen. Quotient of powers, again, when the bases are the same, right? In this case, then I would subtract the exponents. So I'll have m minus n. And then the power of a quotient, again, is kind of like the power of a product. If I have an a divided by b, sometimes it helps if I can separate them and have a to the nth power divided by b raised to the nth power. And again, they're kind of showing you there with the third root. So 27, the third root of 27, or 27 raised to the 1/3 power is 3. And the 64 raised to the 1/3 power, the third root of 64 is 4. All right, so example 1, I've got a bunch of examples here for you. So example 1, 13 to the 1/3 times 13 raised to the 1/6. All right, so again, the bases are the same. They're 13, so I can say I have 13. And then I'm going to take the 1/3 plus the 1/6. All right. Again, remember on that, I'm going to have a common denominator. So 1/3, the same as 2/6. So I multiplied the top and the bottom by 2 to get a common denominator. And then I'll have 13 raised to the 1/2 power, because 3/6 reduces to 1/2. For b, again, I have 5 raised to the 1/5 power times 8 raised to the 1/4 power. All of that is raised to the 5th power. So I can separate them. So I'll have 5 raised to the 1/5 power raised to the 5th power times 8 raised to the 1/4 power. Again, that one is raised to the 5th power. 1/5 times 5 is just going to be 1. So I'm just going to have 5 there. And then 8 times 1/4. Again, if you want to think of this as 5 over 1, then you'll have that times 8 to the 5/4 power. And don't multiply them together and tell me that's 40 raised to the 5/4 power, because that's not the case. All right, C, I have 12 to the 3rd power times 9 raised to the 3rd power. And again, that is raised to the negative 1/3 power. So I can write this as 12 to the third power raised to the negative 1/3 power times 9 cubed raised to the negative 1/3 power, which is equal to 12 raised to the negative first power times 9 raised to the negative first power. Again, since they are negative exponents, I can now bring them down. So I'll have 1 over 12 times 1 over 9. And now since they're numbers, I can multiply those together. And I'll have 1 over 108. On D, again, I have bases are the same. If I don't have an exponent, it's understood to be 1. So I'll have 8. Again, since the bases are the same and I'm dividing, I can subtract the exponents. Again, 1 is the same as 9/9 minus 1/9. So then we should get 8 raised to the 8/9 power. And E, 56 to the 1 raised to the 1/4 power divided by 8 raised to the 1/4 power, all of that raised to the third power. I'm going to state that as 56 divided by 8 raised to the 1/4 power. Again, I'm going to take all of that and raise it to the third power. Now, if you notice, what I did here is, since the bases were the same, I can bring that out. Remember, I can use both of those and do the opposite ones here, because on this one here, it makes sense, because 56 divided by 8 is 7. So now I just have 7 raised to the 1/4 power, and that is raised to the third power. And again, a power raised to power, I multiply, so I'll have 7 raised to the 3/4 power. Okay, now we're gonna, those were the properties of exponents. We have the properties of powers, of radicals, so let a and b be real numbers and let n be an integer greater than 1. So the product property, again, you have used both of these with just square roots though. So on this one here, we have n to the the nth root of a times b. I can write that as the nth root of a times the nth root of b. And then on the quotient property, the nth root of a divided by b, I can write that as the nth root of a divided by the nth root of b. Again, b can't equal 0. And again, they give you a couple of examples there. Again, using it in 2 different ways. So example 2, use the property of radicals to simplify each expression. So again, you can bring them together. So I can take the third root of 4 times 128. And if I do that, I'll have the third root of 512. And everybody knows that the third root of 512 is 8. I'm just kidding. We all don't know that. Okay, I'm going to do the same thing here. Okay. I can write this as, oops. Sorry. I'm going to bring them together. So that'll give me 192 over 6 for the fifth root. That'll give me the fifth root of 32. And the fifth root of 32 is equal to 2. So lastly, an expression involving a radical with index n is in simplest form when no radicand has perfect nth powers as factors other than 1, no radicands contain fractions, and no radicals appear in the denominator. To meet the last 2 conditions, rationalize the denominator by multiplying the expression by the appropriate form of 1 that eliminates the radical form from the denominator. So here off to the side here, let's look at one that we've done before. So if I have 1 over the square root of 7, all right? Again, we can't have a radical on the bottom, so we rationalize it by saying since we're going to multiply the top and the bottom by 1, which is the square root of 7 divided by the square root of 7. Okay? So then if you think about it, again, let's go ahead and put our n is equal to 2 there. That might help you out here. All right? So then I'll have the square root of 7 on the top and on the bottom. Remember, I need 2 of those to just get the number, so I have that. So again, on the bottom, it would just be 7. All right? So think about stuff like that as we work on these next 3 examples. Okay? So A, the square root of, the cube root of 500. All right? Again, eventually you're going to start recognizing some of the powers here and the cube roots and stuff like that. So on this one here, I know that I can take this and write it as 125 times 4. All right? The cubed root of 125 times the cubed root of 4. All right? So the cubed root of 125 is 5. And then I can't do anything more with the cubed root of 4, so that stays there. All right? So what you're trying to do is you're trying to get a whole number somewhere if you can. All right? So on this next one, we have 1 over the cubed root of 49. All right? Now here's where we're going to kind of see something. All right? So I have the cubed root, and what do you know about 49? Well, that's 7 squared. Okay? So now here's the key, ladies and gentlemen. I have an index of 3 here. I have 2 here. Remember, I said I need to make something so that it becomes a 1 down there. All right? So what you have to think about here is I have 7 squared, but I have a 3 here. So if I can multiply the top and the bottom by the cubed root of 7, and on this time here, think of it as I'm putting a 1 there. All right? Think of it like that. I don't have to put the 1 there because it's understood, but in this case, I'm kind of showing you that's what we're going to do. Because now, on the bottom, if you think about it, I'll have the cubed root of 7 cubed, and on the top of the cubed root of 7. Now, since I have a cubed here and a cubed here, then they can go away, and it just becomes the number. So the top now, I had 1 times the cubed root of 7, so I'll have the cubed root of 7, and on the bottom, I will have 7. All right? And then on the last one here, we're going to do the same kind of thing. So I have the 4th root of 19. On the bottom, I have the 4th root of 2 squared. So I have, again, think about it. I have 2 there. I need to get 4. So I have to multiply the top and the bottom by the 4th root of 2 squared. Okay? So again, let me go ahead and write that again. So now I have the 4th root of 19 times the 4th root of 2 squared, or 4. And on the bottom, I have the 4th root of 2 to the 4th. Okay? So on the bottom, you'll agree with me now, it's just going to be 2. And on the top, again, I want 1 radical. So on the top, I'm going to multiply the 19 and the 4. And if I multiply those together, my final answer is the 4th root of 76 divided by 2. Thank you.